Hello, and welcome to this second film in the series of films about solutions. It's about concentration, this one, and in other words, it's about measuring how much solute is dissolved in a solvent. Hopefully, by the end of this film, you're going to know 3 different units for measuring concentration, and you will have seen some example calculations that involve those units. Okay, we'll start off with the least often used unit, and that is percent. Okay, it can be it's often by mass, but it can also be by volume. Okay, so this is the symbols used for mass, so the weight of solute in a weight of solution is a volume of solute in a volume of solution. Okay, it's quite simple, really. In this mixture, which I've forgotten what I cut and pasted here, but anyway, palm kernel cake is 17.8% of it. God knows what palm kernel cake is, but anyway, 17.8%. So in other words, 17.8 grams out of every 100 grams are palm kernel cake. All right, I could equally well have 20% sodium chloride by mass in an aqueous solution, and that would mean 20 grams out of every 100 grams of solution would be sodium chloride. Okay, so it's quite a simple thing. Here is an example that uses volume instead of mass, but it's exactly the same idea. It refers to methylated spirits, which are basically ethanol with poisons added, so you can't use it to make your own alcoholic drinks at home. The question asks, how many milliliters of ethanol are there in 2 liters of methylated spirits? Well, we know that 96% of that 2 liters is going to be ethanol. 2 liters is 2,000 milliliters. It is absolutely vital that you know the conversion between milliliters and liters. Okay, so there's 1,000 milliliters in every liter. How many of those will be ethanol? Well, 96% is 0.96. So if you multiply 2,000 by 0.96, you get 1,920 milliliters. Okay, so that's what we mean by percentage concentrations. Very, very simple indeed. If you can do percentages, you can do those. Okay, we'll move on to grams per litre. This is a much more commonly seen unit. Okay, this particular label is off a Gerolsteiner bottle, which is a mineral water that sponsors a cycling team. You might have seen them in the Tour de France. But anyway, here we've got the concentration of these various minerals given not in actually grams per litre here, but milligrams per litre. Here's another very important conversion. Very important conversion. It's 1,000 milligrams equals 1 gram. So in other words, this is 0.345 grams per litre, okay, of calcium in this mineral water. What this means is we're taking the mass and we're dividing it by a volume. Here's our mass divided by a volume. So if we're going to do a calculation of these sort of things, that's all we have to do. We have to decide what is the mass of the solute and divide it by the volume of the solution. Okay, so here we have 28 grams of sugar in this famous soft drink. Okay, and there's 240 milliliters of that drink contain this amount of solute. Okay, so the mass of our solute in grams is 28. The volume of our solution, which has to be in liters because we're doing grams per liter, is 0.240 because there are 240 milliliters and 1,000 milliliters in a liter, and that is equal to, I haven't done it in my head, but I just got it on my calculator line here, it's equal to 117 grams per liter. Okay, it doesn't matter if you write it like that or in this kind of notation, means exactly the same thing. Okay, so grams liters to the -1 means the same as grams per liter. Okay, moving on to moles per litre. This is by far the most commonly used unit, and it involves a formula which is absolutely crucial when we're talking about solutions. Moles per litre. Moles, remember, is given the symbol N. That's a number of moles. Per meaning divided. Litres are a measure of volume. So concentration is equal to the number of moles divided by the volume. Right? We can get that from the unit, moles per litre, moles divided by volume. Okay, various ways you see this unit represented. Okay, here's hydrochloric acid concentration of 2 moles per litre. Okay, you could also write it as moles divided by litres, means the same thing. Okay, sometimes you'll see this notation. Okay, this reads sodium chloride 5 molar. Okay, and this capital M is just an abbreviation for moles per litre. Okay, well, let's just finish up with an example of finding a concentration in moles per litre. Okay, we're actually told that the sodium chloride has a solubility of 36 grams for every 100 grams of water. What is the concentration of a saturated solution? So that we've dissolved as much as we can. In other words, we've dissolved 36 grams in every 100 grams of water at this temperature in moles per litre. Well, I'm going to have to turn my grams into moles, and I'm going to have to turn that 100 grams of water into litres of solution. Okay, because remember, moles per litre, concentration equals number of moles divided by volume. Don't have a number of moles, I'm told the mass, but I know that number of moles is the mass over the molar mass. Okay, and I know the formula is NaCl, so I can calculate the molar mass. 100 grams of water. It's good to know that 1 milliliter of water weighs 1 gram, so this is 100 milliliters. But remember, I want it in liters, so that's going to be 0.1 liters because there are 1,000 milliliters in 1 liter. Okay, let's find out what the number of moles is going to be. That is going to be the mass, 36 grams, divided by the molar mass, which is 23 plus 35.5. So that's 58.5, and that equals 0.615 moles. Okay, so I found the number of moles, I found the volume of the solution, so the concentration is 0.615 moles divided by the volume of the solution, 0.1 litres, which is the same thing as 6.15 moles per litre. Okay, so you can see there that when we're using moles per litre, we should quite easily, really, using the formulas that we know from before, be able to turn masses into moles. Okay, so in other words, if you're told the concentration in grams per litre, which was kind of what we were told here, except we had to do a little conversion, should be able to turn that into moles per litre. All right, have a look at the calculations that we've done in this film. Got any difficulties with them, come and get some help with them because they're so important. And if you're happy with those, then move on to the third film, which is about ion concentrations.